Hello and welcome to a Simplilearn webinar, Beyond the Textbook, Decision Analytic Principles for Data Scientists. Our guest today is Brad Powley from Salesforce. More about him in a minute. And what we will do now is share with you a few instructions for how to interact with us during the webinar.
Oops.
So we have a Q&A button, which is the square with the question mark. If you don't see that, the three dots will get you there. And if you enter your question, it will be logged for the Q&A period of the webinar at the end of the session. Also, we'll be asking you to interact with us with chat, which is the speech bubble button. Please set your setting to all panelists and ask all panelists your chat questions. There will be a couple of times when Brad asks you to do this specifically so that he can look at a couple of those live. And with that, I will introduce Brad. Welcome, Brad.
Thank you, Stuart. And thank you to Simplilearn for this opportunity. Just let me say a few words about myself before we get started. I work at Salesforce on a team of machine learning engineers, and our team works on data products for delivering insights to customers. We use, like I said, machine learning quite a bit and distributed data processing. But I haven't always worked in this field. Before joining Salesforce, I worked in strategy consulting. I worked for a boutique firm called Strategic Decisions Group. And in that firm, I helped clients make kind of high stakes decisions across industries, energy, life sciences, real estate, IT, manufacturing, et cetera. And before that, I was an engineer. And so my engineering experience is also quite diverse, from mechanical design to manufacturing, systems engineering, and then finally software development. In the middle of all of that, I got a PhD, and my research in my studies focused on a field called decision analysis. And I'm particularly interested in decision making and its intersection with artificial intelligence. Okay, so before we get started, I have a compulsory slide to show you from my employer. And among other things, what it's saying is don't make investment decisions solely based on what you see in this particular presentation. And there are more details here as well, but this is just a forward-looking statement. Okay. So before we get started, it's really important to me that we define a handful of distinctions. The first set of distinctions is related to data. And I think this is important, particularly important, because this is very important to my PhD advisor, I should say, that we want to distinguish ambiguity from uncertainty, because uncertainty is really important in decision making. And we don't want ambiguity around definitions to impinge on that uncertainty. We don't want to add to our uncertainty. It looks like we have some questions, Stuart. I wonder if I can mute my chat. If you could hold.
Yeah, you should be able to just close the chat window for the time being.
Okay, it's sending notifications. Anyway. So let's work through these definitions. So the first definition relates to data. So unless otherwise stated, when I'm talking about data, I'm talking about the recorded facts that a person uses to make predictions. I'm not talking about for the purpose of entertainment or nostalgia or record keeping, et cetera. So for example, when I talk about data, I'm not talking about the information in your data plan, for example. I'm talking about data in the context of prediction. When I talk about data product, I'm talking about an application that uses data to make predictions. So an example of this might be Gmail. So with Gmail, there's a product that classifies your inbox into 3 different categories: primary, social, and promotional. And basically, it's taking information from your emails and predicting how you would classify it and putting the emails in those various buckets. Okay, so that's an example of a data product. Another example of a data product might be a lane keeping feature in an automobile. Okay, and then data science. So this is just, to me, I like to cast a wide tent here. This is just the discipline of deriving meaning from data. The fourth definition I'd like to talk about, and this is perhaps the most important one, is that of a decision. So when I talk about a decision, I'm talking about an irrevocable allocation of resources. I'm not talking about an expression of intent. So what I mean by that is, it's not a decision to say, I'm going to go buy a car today. The decision happens when you write the check and hand it over. Okay, so it's not an expression of intent, it's an allocation of resources, it's an action. The fifth item is decision analysis, and this is a field that helps decision makers achieve clarity of action. So one thing that's really difficult with decisions is knowing what to do, and this is one field that helps people know what to do when they're faced with a decision. And then finally, I'll mention a decision professional occasionally, and this is just somebody who practices decision analysis. Okay, so a word about decision analysis. It's a field that's existed for about 50 years. It was developed by Howard Rafa at Harvard University and Ronald A. Howard at Stanford University, the latter of whom was my PhD advisor. Okay, so now that we have sort of a common understanding of these key definitions, let's move forward and motivate this talk. So there's evidence that companies that are able to extract value from data are the companies that are the most valuable. Okay, so this infographic is particularly telling. What it shows is various snapshots of the top 10 valued companies in the US by market capitalization. Okay, so it starts in 1917. If you look at the companies, they're largely commodities companies, natural resources companies like Standard Oil, US Steel, US Rubber, et cetera. You fast forward 50 years and you begin to see more finished goods companies like General Motors, Consumer Products, Eastman Kodak, et cetera. There's a little bit of encroachment from data companies. For example, IBM shows up at the top of the list. But companies that extract value from data do not dominate this list. But then you look 50 years into the future, and now the dominance shows, right? So we have Apple, Alphabet, which is Google's parent company, Microsoft, Amazon, and Facebook being the top 5 out of the list of 10. And you might say, well, that's just the US. So I looked to get some information globally of market capitalization, and it largely tells the same story. Outside of Saudi Aramco, which topped the list in 2019, we have the same 5 companies from the US, and add to that 2 more data-focused companies, Alibaba Group and Tencent. And so the list even looks more dominant by data-driven companies. Okay, so you might think, okay, well, that's looking into the past. Like, what are the trends? Well, it just so happens that the storage of data, the capacity to store data, has been growing at an exponential rate. And if we look at this chart, what we see, it plots the number of bytes of global data storage against time. Okay, so you can ignore the blue and green curves and just look at the gray curve, which is the sum of those two. And what this shows, and by the way, the y-axis is a log plot, so each tick on this y-axis is 10 times more than the previous tick. What it shows is that there's exponential growth in the storage of data. And in fact, it's 30% year-over-year growth. And if you think about that, a corollary of that statement is that if you look at the final 3 years, and this is a snapshot in time from a little bit, about 5 years ago, and this is from research done by Professor Martin Hilbert at UC Davis. If you look just at the years 2012 through 2014, as much new data storage capacity went online in those 3 years as existed in previous human history. Think about that for a minute. The amount of data that storage capacity for data is growing at a rapid rate. The only reason it grows at that rate is because we have need for it to grow at that rate. So the point is that data has been important. It will continue to be important. It looks to be that way. And those who understand how to extract value from it will be at an advantage. Okay, so if you look at the popular business literature, you see largely the same story. So here's a quote from BCG Insights, who is a major consultancy in the US, and it says, over the past few years, data has been established as a fundamental source of business value. Okay, so they're seeing the same trends. And you look, okay, at an HBR article, Harvard Business Review, and they say the most valuable and powerful businesses for the foreseeable future will be those that are built both on regular network effects and enhanced by data-enabled learning. Okay, so another case for data being important. And then finally, and this is perhaps the strongest statement from a McKinsey report, which is also a major consultancy in the US, and they say data has become the new corporate asset class. This is amazing, a new corporate asset class. You have stocks, bonds, commodities, and data. I mean, this is a major statement. And so now I'd like to turn it over to you. And so if you could open your chat windows and answer this question just in free text: what gives data its value? So take a moment and answer that question, please. Give your opinion on that. Okay, we have one from Rajneesh Sharma. He says, how can it be analyzed and used? Yeah. From analysis, from Neetu. Good. Power to transform business, the way it is used, visualization, insights that can be derived from it, from Rahul. It's very nice. Yeah, very good. Okay, let's wrap up our answers. I'll give you a couple more seconds to send your final thoughts, and then we'll move on. There lies business values inside it. This is great. Okay, so there are many excellent answers here. Prediction, easily referenceable, really good. Okay, so let's go back to the experts from that business literature and see what they say. So from the MIT Sloan Review, Gandhi and his co-authors last year say this. They say data on its own has value, but insights derived from data substantially increase that value. Okay, we heard some thoughts similar to this in the chat window. Very good. Okay, so that's what they say. Let's move on to the next one. This is from the McKinsey report. It says data in its raw and most basic form is virtually worthless. Okay, that's already in conflict with the MIT Sloan report. It's saying data on its own has value. But then they go on to say, until we give it a voice by gleaning valuable insights from it. Okay, so now there's some agreement. So let's look at the final example. And this one is from a PwC report, another consultancy in the US. And they say the value of data, be that yours or of others, ultimately lies in its usefulness in achieving your strategic goals. Okay, so there's a lot here. And there's a lot here that overlaps nicely with what people answered. And I don't have major argument with any of this, but I also don't think it gets to the root of the question. So what is the root of the question? So here's my argument. In the context of prediction, decisions are what give value to data. And how can we think about this? Let's think about a data value chain. Okay, so we start with data itself. And as someone wrote into the chat window, data enable predictions. So we think that's true. Okay, so with data, we can make predictions. And with predictions, we can help people make better decisions, because oftentimes the thing that stands in the way of a good decision is uncertainty. And predictions can help reduce uncertainty. And decisions themselves are the way that make better futures for themselves, right? This is how people can change their future. And in other words, if I'm going along on sort of a momentum, status quo, sort of a trajectory, and I don't change anything, my future has a certain amount of value to me. If I want to change it, I have to make a decision. I have to take an action, okay? So given all of this, my argument is that data scientists should not only become experts in handling data, visualizing data, etc., they should also have a certain amount of expertise in decision making, because decisions are where the source of the value of data is from. Okay, so let's talk about a few decision analytic principles. I introduced this field of decision analysis early on, and for me, the precepts in this field are the best way that I know of to develop expertise in decision making, to make better decisions. Okay, so I'll call this some old wisdom from a new field, or for a new field, excuse me. Okay, so here's the first principle. Decisions are the way that we change our future. So we just talked about that. So if we want a different future, if we want a future that's of higher value, we need to make decisions. The second one, and this is super important, when uncertainty is involved, okay? When uncertainty is involved, you cannot determine the quality of a decision by the quality of its outcome. Okay, so you cannot determine the quality of a decision by the quality of its outcome. And there are a couple of corollaries to this. One is a good decision never turns bad, and a bad decision never turns good. And there's a lot to unpack here. So let me just elucidate this a little bit by giving an example. Imagine you're a parent and you have a son, and this son is going out with friends. And this son finds himself at a party with his friends. And the people at the party are drinking. And the friend who is driving your son has drunk too much and really should not drive because it would be dangerous. So now your son faces a decision. He can get in the car and be driven home by his drunk friend, or he can call you and have you come and pick him up. Okay? So I think most people would agree that the good decision is that he should call you for a ride and not come home with his drunk friend. Okay, but suppose that he decides to go with his drunk friend, and by happy circumstance, they make it home safely. Does that now make his decision a good decision? Of course not, right? And likewise, if he had called you to come pick him up and you had gotten into a car accident on the way to pick him up, would that have been a bad decision? And again, the answer is no. So a good decision never turns bad, and a bad decision never turns good. And most importantly, we cannot determine the quality of a decision by the quality of its outcome when uncertainty is involved. Okay, so given this, we can and we should be able to assess the quality of a decision before it's made. Because you want to make good decisions. It doesn't do you any good to look back on it because you can't change it. What you want to be able to do is, at the time you're making that decision, be able to assess its quality. Okay, so how would you do that? Well, it turns out that there's a framework for this, and this was developed through decision practitioners back in the 1980s. And the notion is that there's a metaphor of a chain. And in the chain, there are 6 different elements of decision quality, okay? And the metaphor of the chain is such that the quality of your decision is only as strong as the strength of its weakest link, okay? So you need all of these things to have a high quality decision. So let's talk through the 6. And I think this is a really nice framework to use because it allows people to have conversations about whether a decision is good or not before it's made. So the first item is the frame. So the frame of a decision is, if I can just distill it into a few words, it's the decision's purpose and its bounds. So what is it you're trying to do, and what are you deciding, and what are you not deciding, right? What are you including as a possible alternative, and what are you excluding? And that's what I mean by bounds. Now, the second item is alternatives. So alternatives are a decision set of possible actions. So every decision consists of a set of alternatives, and these are the things we could do. In the case of the example I gave with the son at the party, his alternatives were twofold. 1, he can go with his drunk friend, or 2, he can call his parents and get picked up. Perhaps there's a third decision. Perhaps he could have walked home. Perhaps there's a fourth, alternative. Perhaps he could have called a taxi. Okay, so this is the set of alternatives, the things you can do. Third, we have information. And this is where data come into play. So this is all the data, experience, judgment, etc. you can bring to bear in making the decision. Okay, that's the information component. Next, we'll go to trade-offs. And trade-offs is a means for comparing the value of different combinations of competing factors. So there are lots of trade-offs that can be faced in decisions. For policymakers, it could be a trade-off between the amount of money you spend versus the amount of safety or the amount of lives you save in a country, for example. A classic engineering trade-off is threefold. It's between the cost of developing a product, the quality of that product, and the time it takes to develop that product. So that's like the three things. Oftentimes, if you want to do better on two of those three things, you have to give up on one. So in other words, if you want a product that has higher quality and you want it to not cost very much, it may take longer to develop, for example. Fifth, we have reasoning. And reasoning is just the logic. It's how you choose an alternative based on the information and trade-offs that you have and the set of alternatives. And then finally, there's commitment. And so if you've gone through the entire process, you've gone through the reasoning, it's clear which alternative is best, do you really have commitment to make the decision that you said you're going to make? Do you really mean it? Okay? So with these 6 things, we can evaluate a decision. So once again, a high quality decision requires each of these 6 elements to be of high quality. Okay, so let's go to a poll. And Stuart, if you could put the poll question up so people could give their answers to this multiple choice question. And the question is, if you work with data, which presumably many of you do, which of these 6 elements should you focus on? So if you could click on your answer and hit submit, I'd appreciate that. And we'll just give about a minute for people to make their selection. And once again, as people are deciding, the frame is the bounds and the purpose for your decision. The alternatives are the things you can do. The information are things like data and experience and judgment that you bring to bear on the decision. The trade-offs are how you decide between competing values, things like cost versus quality, for example. Reasoning is how you tie the whole thing together, the logic that you use. And finally, commitment is whether or not you're willing to make the investment once it's clear which alternative is the best one to choose. Okay, we have a set of results here. And it looks like the winner is information. And with the second place being reasoning. And I think those are reasonable answers. Okay, so what I'm going to say about this is, my answer is, it depends. It depends on what kind of decision we're talking about. And we're going to enter into a case study here in a minute, and that'll give us a chance to talk about different kinds of decisions and how they interact with data scientists. And then given that, which part of decision quality is the one that you want to really focus on. Okay, so let's move forward in that direction. So I want to get into this case study. Before I do, I want to talk a little bit about Salesforce. And many of you may know about Salesforce, some may not. So just from a high level, Salesforce is a software as a service company. It's one of the original software as a service companies. It's been around for about 20 years. And we are passionate about helping our customers be successful. And there are various different markets that we play in. For example, we help with the service market, like service calls, things like that, marketing, etc. Our bread and butter is, and historically has been, the sales market. So we help salespeople sell products and be coordinated and be organized about selling their products to their customers. So we care not only about our customers, which are organizations that have salespeople, but we also care about our customers' customers, the people that they're selling to. And in this case study, you'll see two types of interactions mentioned, and I want to talk about those a little bit just so you have context for them. One is that a salesperson, one of our customers who uses our product, oftentimes may give a sales offer to one of their potential customers, and their potential customer responds with some form of objection. And that objection might be something like, we don't have money now, or the timing isn't right. Can you talk to us next quarter? Or we just don't really need your product, or maybe you should talk to my boss, et cetera. So this is a kind of thing in the sales parlance called an objection. Okay, so that's one kind of interaction we'll talk about. The other one we'll talk about, oftentimes when salespeople are working with an existing account, this is a company they've already sold to before, who may be using one of their products, but they want to sell an additional product to. The customer will come back to them and with an issue for that product, like, hey, you sold us your product and I'm having problems with this particular aspect of your product. And so the salesperson oftentimes will receive complaints about an existing product. And so those are the two things we'll be talking about in this case study. So let's move into the case study. Okay, so we have a product manager, and she's on the left in the pink shirt, and she approaches your data science team, and this is you on the right in the plaid shirt. And she says, we want to automatically alert salespeople when their clients send angry emails. And our customer research shows that when a potential client is angry, time is of the essence. And we want this to be available by the end of Q3. And our data science leader says, well, sentiment classification is a common natural language processing task. We know what to do, but we don't know whether our data will support this idea of an angry email classifier. But he says, we'll look into the data right away. So he goes off with his team to begin a spike to see whether the available data can support this idea. And so a week passes, and he comes back and he says, hey, the spike yields mixed results. We've learned that business emails are very polite. They're more polite than things like tweets and product reviews. And after some quick prototypes, our team agrees that an angry email classifier, while possible, would be difficult to get right on the timeline of this project. And she says, oh, that's bad news. To which he responds, we did, however, notice there are two types of emails with polite but negative feedback. The first is objections to sales offers, and the second is issues with an existing product. And then he asks an important question. He says, are we working on the right problem? And she says, well, let me check with our user experience research team about testing these two ideas with customers. And so she goes off and talks to that team to begin some studies on the idea of automating the classification of sales objection emails and issues. And a week passes again, and apparently they wear the same clothes each week, or on that day each week. And so she comes back and she says, good news. The research suggests that people were excited about an automated system for identifying and classifying sales objections. And they weren't quite as excited about classifying product issues. And so he says, you know, we think we can build an objection classifier. We think we can do that. And she says, great. I'll put that on our product roadmap. So let's work out a plan to make it successful. So the team decides to pursue an email objection classifier. And now I have a question for you that I would ask you to open the chat window again and give your responses to. We'll keep it open for about a minute. And here's my question, poll question number 3. Please enter via the chat window. And the question is, what could go wrong in this project? So presumably...
May I just ask, if you use to everyone in this chat window, other people will be able to see your responses. I think we've had some questions from the audience about that. So if you use to everyone to answer this question, that would be helpful.
Thank you, Stuart. So presumably many of you have had experience working on data projects, or have at least been in the room when such decisions are made. And so you have a sense for what might go wrong. And so the question is, what do you think might go wrong? Oops. This is nice. Difficulties in classifying mixed emotions. Very good. Yeah, so we might have a technical difficulty. For example, oftentimes when people object to something, they're exceedingly polite. They say, "Oh, thank you very much, but the timing just isn't right now. But we really enjoyed the demo you gave us." It's really hard to extract an objection from that, but there is an objection. So there's another one: difficulty in classification. These are all technical difficulties. What about difficulties organizationally? What thoughts do people have about that? Inconsistencies in the data. Typos, underlying meanings. Yeah, for sure. Okay, let's give this about 30 more seconds. Type in what you think might go wrong, and we can talk more about that. The primary objective of the project has changed, right? And it did change. What is going to be done with the insights later is not clear. Lack of concepts. One might say lack of alternatives, right? Maybe the solution won't provide enough business value, right? That's good. Okay, so let's wrap this up. These are really great responses, and I think they're all reasonable. And they show a level of experience that people have. So let's think about this rather than an unstructured way where we just give our ideas of what could go wrong, and let's actually structure it in the context of decision quality. Okay, so we'll start with frame, and the question is, does the data product decision have a good frame? Okay, so we'll just start with one of those links in the chain. And so here's some questions we could ask. So the first one is, does the project team have a common purpose? And I'd say possibly. It seems like they share the value that they want to improve salespeople's effectiveness through smart data products. I mean, I'm inferring that, but I'm not too worried about that one. Well, how about, do they have a shared perspective? And I'd say not initially. Sharing a perspective includes a common understanding of the issues of various stakeholders. And stakeholders are the people who are affected by an individual's decision. Okay, so in this case, the stakeholders are not only her, the product manager, but also the engineering team, right? And so at the beginning, she hadn't really considered what the data enabled. But eventually they got there, right? Eventually they talked about it. She gave him space to do a study and then give feedback. And then finally, is it an appropriately scoped decision? Is it big enough? Is it small enough? Well, as initially framed, it's not appropriately scoped. An angry email classifier is a smart data product, but it's not what the team could do given the time that they were given. But eventually they got there. And so it's hard to give an answer because we don't know a lot of the backstory of this case study, which is fine. But it suffices to say that the project team should test the frame until there's agreement that it's appropriate. In other words, the two of them should say, like, if they have any particular issues, those issues should be raised. If they feel like the decision should be constrained to be smaller, or if it should be expanded to be bigger, right? They should talk about that until finally they agree on the frame being appropriate. All right, so let's talk about failure modes that could stop a product decision from having a good frame. The first is, and I see this one quite a bit actually, is that data scientists just accept the frame they're given without challenging it. And this would have happened had our engineering lead said, great, angry email classifier, we'll just do that, right? If he'd accepted that without saying, hey, we need to investigate it, that's what I'm talking about here. That leads to problems. And so I sometimes see data scientists treating requests from product management like it's a homework problem, like it's a problem that's been given and I just need to find the answer to it, without questioning whether or not it's the right problem to solve. Okay, another problem I see sometimes is people jump ahead to the technology required to solve it. They might say, oh, you know what? we've been waiting for a chance to use transfer learning. And this is going to be a great chance for us to use transfer learning. We'll get started right away, right? Without, again, saying, is this the right problem to be working? The next one is scoping the decision too narrowly or too broadly. So an example is if the owner of the product roadmap expects a product that the data just aren't going to allow, right? So you can imagine, like, if she wanted a product that told salespeople what to do, but the engineers had no access to sales call data or text data or other sorts of conversations that happen, then you're probably not going to be able to do that. That's probably scoped too broadly. Or likewise, you can have a problem that's scoped too narrowly, where the product team is unclear about the decision's value and they just aim too low because they want to work on something they know will be a technical success, whether or not it's a marketing success. And you need both. And finally, the failure mode of excluding other stakeholders' frames. And I want to talk about this a little bit right now. So a few thoughts on the frames of other stakeholders. So I'm talking about a decision around whether or not to pursue a data product. That's not the only kind of decision we're faced, right? We face all sorts of decisions, and one of which, as data scientists, is, for example, what other people, what sorts of decisions other people are making and their frames for those decisions. So we can improve the project by considering the frames of other stakeholders. Like, we can think about the decisions of the salespeople, who are the users of our data product. What do they want to inform? We're giving them a prediction. What decision is that prediction helping with? And what frame do people who decide whether to purchase the product take? So we may be thinking about salespeople, but perhaps we should be thinking also about their managers, because maybe the managers of salespeople, both are customers, but perhaps their managers are the ones who are going to make the purchase decisions, right? We can also think about our team's data product decision can be nested within the broader organization's decision making. So we may have internal executives who decide about funding and strategic direction, and those decisions constrain the frame of our decision. So, for example, it would make no sense to pursue this objection classifier if our leadership had a stated goal of doing voice-to-text transcriptions of sales calls and extracting information to give back to salespeople about sales calls. Right? If that's the stated direction, we shouldn't be working on something that's in conflict with that. And that's all about the frame of our leaders. And then finally, data scientists themselves have decisions within the product decision. So once we decide, yes, we're going to go after an objection classifier, our data scientists have to begin making decisions like, well, what sort of architecture should I use to build it? How is this going to fit inside of our tech stack? All those kinds of things are decisions that get made after we make the decision about what product to pursue. And when we make the decision about what product to pursue, we should be thinking about all these other kinds of decisions. How our customers are going to use our product, how our product fits in with the broader organization's stated goals, and whether or not our team is going to be able to make good decisions around the product decision. Okay, so let's move on to alternatives. Okay, so this is the second component we'll talk about. And so the question is, does the data product decision have a good set of alternatives? And we can test that. So some questions we should ask. Number one, is the alternative we're pursuing feasible? I mean, this is the most obvious question, right? Is this something we think we can do? And in the case of our case study, at the outset, no. The data and the timeline simply did not support what we needed to be able to get done. But eventually, yes. So our product manager was wise enough to let the engineering team have enough space to study this. And eventually, given that and given the user experience research, they agreed it was both possible and valuable. And then the next question is, have we considered a set of alternatives or just one? So this is a common thing that we see as a failure mode, in fact, is that only one alternative is considered. So initially, the product manager only considered one, that she wanted an angry email classifier, but eventually they got there and they grew the list to 2. And so there's an open question now. Is this enough? Is 2 really enough? Are these 2 particular alternatives really covering the space of good alternatives? And do we have the best alternative within that set? And I recall that one person, when asking what could go wrong in that poll, said, we don't have enough options, right? And so this is a classic failure mode. And then finally, are the range of stakeholder viewpoints represented within the alternative set? So for example, have we spoken to a diverse enough set of customers? If we've spoken to just a handful of customers, but not all of them, we may release a product that satisfies some customers, but not a broad set of customers. Or if we're thinking about expanding our customer base to new industries, are we thinking about those new industries and how they'll interact with our product? I mean, we want to develop something that's going to work now and in the future, not just now. And finally, does this product idea align with the overall direction with our business? We talked about that a little bit with framing, but is this particular alternative that we're pursuing, is it consistent with how our managers and executives are thinking about the direction of the business? Okay. So this is an important principle, and it is that the decision we make can only be as good as our best alternative. So if by failure of imagination or because we're too risk averse, we've left the best alternative outside of our frame, then we're leaving value on the table, and we don't want to do that. We want to make sure we have the best alternative in our set of alternatives. So we've talked a little bit about failure modes here, but let's just go through them quickly. So here are 3 kind of classic failure modes. This is not an exhaustive list, but it is a list that's reasonable. The first is we have a project team with 1 or very few alternatives. We talked about that. The second is data scientists being order takers. So the product manager comes in and says, make me an, and then fill in the blank. And then the data science team just says, right on, we'll just do that without questioning anything. And then finally, project teams failing to have an ethical framework for removing data product alternatives that they should not be considering, right? So this can get people into trouble. Okay, so let's move from alternatives onto values and trade-offs. So here are some questions we can ask in this case study about values and trade-offs. And the first is, are there explicit value measures for evaluating the alternatives? In other words, do we have a number we can place on one alternative versus another to be able to say one is better than another? And the answer is, as far as we know, these value measures are implicit. We never talk about numbers. We just talk about a successful UX study that she brings up and a feasible modeling task, which he brought up. But there may be lots of alternatives that meet these 2 criteria. So how would we choose between them if we had yet more alternatives on the list, right? The next one is, are the value measures appropriate? And given the project team is only considering 2 alternatives and it's clear that one is a lot better than the other, then using just an implicit value measure may be sufficient. You may not need to put things into numbers because it's pretty obvious which one you should pursue. But then a question comes up, how would we know if this data product were successful? If we don't have any way of measuring it, then how would we know it's successful? So I'm not saying that every decision requires a value measure, but it's something worth asking, especially if there are competing things that you're trading off, like the time to market for a particular feature you're working on, or the level of quality you're working on with that feature, or the amount of cost that the product will incur, right? So when you're thinking about things like that, it can be really useful to use numbers. And then finally, when objectives conflict, is it clear how we make trade-offs between them? So, feasibility of modeling tasks and the results of UX study aren't binary, right? They're usually on a continuum. And so if no alternative is obviously best, how do we trade them off? So for example, imagine that the objection classifier were more feasible, but it did worse in the user experience study than the issue classifier, which was a little less feasible, but looked like it was more valuable to the customer. Now you have 2 things in conflict. How do you trade those 2 things off? And that's talking about the clear values and trade-offs link of the chain. Okay, so I want to make a quick run through the failure modes that prevent clear values and trade-offs. So one is teams fail to discuss value measures. Like we're talking about quality, but we never have a way of measuring quality in the product, for example. Another is the project team does not know how competing values should be traded off. For example, model accuracy versus development time. A friend of mine, John Mark Augusta, he likes to refer to the cult of model accuracy, where all you do is just, as a data scientist, is just try to make things more accurate and more accurate and more accurate. And at some point, you're doing more harm than good because you're delaying that particular feature from getting into customers' hands and delivering them value. Okay, the third is data scientists end up sequestered deep inside of an organization and never actually talk with customers. And so then they're just relegated to looking at clicks or other such measures that lose the narrative about how the product is being used and what customers care about. And I think both are important. And then finally, data scientists being data-driven yet blind to value. So you really, to really empathize with your customer, you need to understand what your customer cares about and be driven by what they value. Whereas being data-driven is a good thing, also being values-driven is a good thing. And frankly, if I had to choose between the two, I would lean a little more toward being value-driven even than being data-driven. Okay. So I'd like to make a quick note on alternatives and trade-offs, or you could call trade-offs values, how you value things. And that is that data scientists and decision professionals tend to think, and executives tend to think in different directions. So we have a Venn diagram here. On the left, we have what is possible with the data. And on the right, we have what is valuable to the user or the decision maker, right? What is possible with the data on the left, what is valuable to the user on the right. And really, you could think about these two sets as the set of things on the left that are technically feasible, that define technical success, and the set of things on the right are the things that define marketing success, okay? You want to work as engineers working on data products, you want to work on the intersection between these two sets. You want to deliver valuable data products, right? And so where do you start? Well, decision makers, executives, decision professionals tend to think from right to left. They tend to, as the McKinsey report quote says, they tend to work business backward and not data forward. Right? They start with what's valuable from a business standpoint and then see whether or not the data can support that. And you think, okay, that makes sense. But actually, data scientists tend to think in the other direction. So they think first what's possible with the data and then what's valuable to the decision maker. And here's a nice quote by a Nobel Prize-winning economist named Robert Shiller. And he says, some of the best theorizing comes after collecting data, because then you become aware of another reality. And if I can reinterpret that from a decision frame, I could say, look, once I look at the data, it may uncover new alternatives that I had never considered before because I just wasn't aware that they'd be a possibility, right? So there are two different ways to think about this. And if Stuart, if you can queue up the poll question number 4. And here's poll question number 4. What is the best way to think? Should you start A, with what is possible with the data, or should you start with what is valuable to the decision maker? So if we could just take about 15 seconds and just give your opinion on this, choose A or B and click submit. So again, just to let you remember what the Venn diagram was, on the left was starting with the data, or was working with what was feasible with the data. On the right is working with what's valuable to the decision maker, and the intersection is where data products should reside. And the question is, do you start with the data, or do you start with what's valuable to the decision maker? Should you be values focused first or data driven? And I'm a bit surprised. So the winner is by about almost a 2-to-1 margin is starting with what's valuable to the decision maker. And you surprised me. And my answer to this is my particular answer. This would have been my answer in the past, I think. And now that I've been working, building models, working as a machine learning engineer, working with data, I actually have a new opinion. And my opinion is this, that you really want both, right? And I'm not trying to get around this question. I really mean this. So like, as a data scientist, you should be familiar with your data. You should be have a deep understanding of what's available. But at the same time, you should also have a certain understanding of what's valuable to your customers. So you should be constantly interacting with customers as much as you can, right? Be that listening in on user surveys or talking to people that use the product. Because what that does is it makes you more sensitive as you're looking through the data as to what new alternatives might be good ones, right? And likewise, I think from the product management side, I think that they should be to a certain degree familiar with the data, right? And for the same reason, they should have a sense for what's feasible and what's not feasible. And the way we've done this with our product managers is we've actually had them get involved with labeling data, right? So we have data that we want to use for training in a model, and those data for supervised learning need to be they need to be labeled. And so we actually have our product managers spend some time labeling a few hundred examples. And this does a world of good. It gives them a sense of what's out there. It makes things less abstract for them. And on the other side, we have been having our data scientists sit in on customer interviews that our UX team conducts so that they can hear first person from users of a product about what's important to them. So I think there's value in understanding both sides and kind of iterating between the two. Okay, so what are some failure modes that I'm going to skip ahead to information and logic links and kind of do them together in the interest of time. So for information failures, some failure modes we might see there are user studies that reflect the present world but not the future. Someone I know was working on trends, sort of fashion trends, and their company wanted to use user studies today to see whether or not a product should pursue one direction or another. And her argument was, look, you're talking about today, but people's tastes change according to fashion. We shouldn't be talking with users for this. We should be talking with trendsetters, experts in how trends change, right? So that's one way for an information failure, is that you don't think about, I guess in North America, you'd call that skating to where the puck will be, not to where it is. The second one is seeking new data when it won't change a decision. So from an organizational standpoint, as soon as you have enough data to make a decision, getting more is not going to be helpful, and it's not valuable. It's just going to slow things down. So this is a classic information failure. And then finally, not recognizing an undesirable type of bias in the training data. Okay, and then for failures of logic, there's one main failure of logic, which is lacking some coherent means of combining information and trade-offs to identify the best alternative in the set of alternatives you have. That's it. Okay, so let's move toward poll question number 5. And we will do this via the chat window once again. And the question is, does our team have commitment to action? And why or why not? So go ahead and open your... Oh, excuse me. Not the chat window. Sorry, Stuart. Can you bring up the polling window again? I'd forgotten that this was a multiple choice. Thank you. So let's just take 30 seconds to fill this in. And so, does the team have commitment to action? Why or why not? Answer A says yes, once the objection classifier is on the product roadmap. We know they have commitment to action. Answer B says yes, because the product manager and data scientist lead verbally agree. And then answer C says no, because they have not yet worked out a project plan. So let's take just a few more seconds to enter into this poll. Okay, Stuart, maybe let's close it in about a few more seconds. Okay, so the winner is, looks like it's C. They don't have commitment to action because they have not yet worked out a project plan. Okay. And so that's a close second is A, which is yes, once the objection classifier is on the product roadmap. And I think that my answer to this is, I think probably the best answer is A, but there's still room for failure modes. But at least in our organization, once a product is on the roadmap, it signifies that it's acceptable for people to begin applying resources to that project. So simply being on the product roadmap is a strong indicator that a particular data product decision, in our case, has commitment to action. But there are still potential failure modes. So let's talk about whether or not the team has commitment to action. So one question for knowing is, does the team or decision maker allocate enough resources to implement the decision? And in the case study, the indicators of commitment are that the data science team assigns sufficient people to the project, and the project manager gets it on the product roadmap. So that seems reasonable. We don't know whether or not the data science team actually assigns sufficient people. That's left to our imagination. The second one is, given the product meets the minimum requirements, does the product manager greenlight the feature to be added to a generally available software release? So in other words, if the team succeeds and the market doesn't shift, does the feature go GA? So these are two kind of indicators that there is commitment to action. That second one is not terribly useful because we won't know it until after the decision was taken, right? The first one is something we will know. Okay, so failure modes for commitment to action. The first is the chosen project is starved for resources, right? So everybody says, yeah, great, let's pursue this objection classifier, but then they can't find anybody to work on it. The second one, and I've occasionally seen this in my career, where a particular project is not given enough official support to where resources can be applied to it, but some kind of middle-level manager, it's a pet project for them, and so they unofficially carve out some time for people on their team to work on it, a so-called skunk works, where you have this team in secret working on some project idea, rather than being on the official project roadmap. Well, to me, when that happens, that suggests that there was never any true commitment organizationally to pursue this project. And then finally, and again, these failure mode lists are not exhaustive, these are just examples. But finally, important stakeholders fail to get behind the project. For example, the app team doesn't have the objection feature on their roadmap. So all the back-end teams are ready to go, they're fully resourced, they have what they need to deliver their part of the product, but then no one on the UI end, no one on the receiving end from the front end teams is available to help put this thing into production, right? So that's another example of a lack of organizational commitment. Okay, so let's summarize what we talked about today. I want to hit the high points. So the first one is people recognize how valuable data is. Clearly, the people in this seminar must also, or else you probably wouldn't be here. And the second thing is, in the context of prediction, data gets its value from the decisions it informs. And I think this is really important. And then the third thing is, data scientists should have a framework for thinking and communicating about decisions. And I posit that this decision quality framework is the right one to use. It's a very useful framework, and it comes from the field of decision analysis. And then finally, and I want to spend a little time on this particular framework for decision quality can help data scientists avoid failure modes that you see commonly in this field. And they can help by, one, communicating more clearly with their stakeholders, product managers. So you can imagine if a product manager is working with this language, with this framework, and an engineer is working with this framework, now you can say things like, I want to challenge your frame on this particular decision. Or have we considered this other alternative? Or do we really know how to trade off these two competing factors, right? Or how do we know that we have commitment for this particular decision that we're taking, right? So it gives you a language to use. Secondly, it gives space to challenge ill-framed product ideas. So if we agree that we're working with this decision quality framework, it kind of makes it okay to say, you know what, I don't agree with your frame, or can you help me understand your frame better, right? Third, it helps you better empathize with the users of your models, right? So if you have this decision framework, you can think about the decisions not only that you are making, that your organization is making, but also that the users of your predictions are making, right? And when you do that, you can think about what they value. You can talk to them. And immediately when you start talking to someone about what they value, how they trade things off, you better empathize with them, which makes you better at designing products that they will like. And then finally, having a framework can help you more explicitly consider ethics in your products. So if you have a specific organizational ethic around doing something or not doing something, especially if it's not doing something, then any alternative that does that thing should be excluded immediately. Then you don't have to spend any more time on it, right? So these are just some examples of how this framework can be helpful for data scientists. So with that, I want to leave you with a handful of resources. The first of which is a book on this subject. It's a very readable book. It's called Decision Quality. It's written from a more broad standpoint. It's not in the context of data science. It's just in the context of decision quality. It's called Value Creation from Better Business Decisions. And this is by Carl Spetzler and Hannah Winter and Jennifer Meyer. And this was written just a few years ago. It's a nice, very accessible book, short book. The next one is called The Foundations of Decision Analysis. This is by my PhD advisor, Ronald A. Howard, and Ali Abbas, who's a professor at USC. And this is a textbook. It's sort of upper division / early graduate school textbook on decision analysis. So if you want to get into kind of more of the details around that, I recommend this book. The next one is called Value Focused Thinking, A Path to Creative Decision Making, and this is by Professor Ralph Keeney. And in this, he argues for starting with value, right? So starting with what you care about when thinking about a decision and allowing that to help you come up with new and creative alternatives. So it's very much going right to left on that Venn diagram we talked about. So it's an argument for that. And then we have the Handbook of Decision Analysis, and this is sort of a professional's handbook, and it's for kind of consultants and decision professionals. If people are interested in that as a field, this is a nice handbook. And then finally, I can point you to a YouTube video of a panel discussion that I hosted last year with a set of data scientists, which is called Bringing Out the Decision Analyst and the Data Scientist. Okay, with that, Stuart, I am wrapped up. So shall we begin our Q&A session?
Yes, we shall. And we have a few questions that came in through our YouTube Live.
Great.
One of which is, I'm in chemical engineering. How can I apply this in my field?
If you're in chemical engineering, this field has been applied more readily to that discipline, I would say, than it has to data science, at least to this point. Now, frankly, every discipline makes decisions, so it's applicable in any discipline. But there is a rich set of literature, at least in the oil and gas and energy industry. There's one book by Patrick Leach called Just Give Me the Number, which I think is a really interesting take, and it's written from an oil and gas perspective, and I think it would be applicable to chemical processing as well. So anytime you face like a design decision or a process change decision or anything like that, I think that you can use this same framework. Like, what do we care about? What are we trading off? There may be a safety versus dollar trade-off that you want to make explicit. What alternatives are we considering, et cetera. So I think it's very applicable in chemical engineering.
One user asks, what exactly do you mean by trade-offs?
Yes. So you can think about different attributes that alternatives have, right? So you can be making a decision about like let's move it beyond data science. Let's say like It's a decision about whether or not to manufacture a good in-house, or whether or not to purchase that good from an OEM supplier. Okay, so you might say, okay, well, we could just look at the dollars, like they'll charge us X dollars. If we make it in-house, it'll cost Y dollars. Okay, but there's other things as well. So for example, you no longer control the quality if someone else is making it. And so how do you trade that off with dollars? How do you know how much you're willing to give in terms of quality performance from this OEM supplier versus the amount of money that you might save by going with them, right? And also, it might be that working with that OEM supplier adds time in your supply chain. And so what's that worth to you as well, right? So you need a way, when you have competing values, a way to be able to say which one is better than the other. That's all trade-offs is.
The last two questions we're going to take both relate to examples from industry. One user asks, can we use preventive analytics in healthcare to prevent getting disease with descriptive and predictive analytics?
Okay. Can we use preventive analytics in healthcare?
I think what he's asking is can we use descriptive and predictive analytics in healthcare as a preventive measure?
Yeah. So when I think about preventive analytics, what I'm thinking about is I'm not familiar with the term, but if I unpack the words, I think, okay, you're making an intervention, right? Like you're doing something, which means you're making an action, which means you're making a decision. So preventive analytics might be using analytics to perhaps make a policy decision, right? So yes, of course, and that should be done, right? Like when people are thinking about, for example, COVID in the U.S., and they're thinking about decisions around whether or not, I don't know, to mandate mask wearing in a particular community, right? So they could look at what do the data say, and given that, which alternative would work best. And so I think descriptive analytics fit under the information link of the chain. And when you start talking about preventive, now you're talking about the alternatives link of the chain because you're taking an action. So it all fits. It all fits. I think a decision analyst would not make those distinctions. They would just say, what data do we have? Maybe they build a probabilistic model out of that data, and then given what that model says and the various actions we can take and the response, the modeled response of those actions, then what should we do?
Mm-hmm.
That's how I'd answer that.
I have a question from a CEO who is learning data science. He asks, how will this help support executive support systems?
Yeah. This is a question, I'm not surprised to get this question. I've heard it before. And, you know, if you talk about, and this is maybe kind of the more classic data science, or I shouldn't say more classic, maybe the part of data science that does things like visualization, dashboarding, et cetera. Oftentimes, those are the things that make their way up to the C-suite. And those kinds of things, as a CEO, are part of your information list. So, so you need to be thinking, I think, on a regular basis, what decisions are we facing? Is our company facing? And then, given those decisions and given what we care about, what sort of information will help inform those things? And then working with your teams to get data to support that information, I think. So that's the way I think about it. That's not to say that people coming within the organization bringing results of models is also not important. In fact, when I was doing strategy consulting, that's pretty much what we did. We worked with CEOs to frame their decisions, and then we built models and worked with our data analytic teams to inform those models, and then came back to the CEO with the results of those models, saying, hey, if you choose A, here's your possible range of outcomes. Here's a probability distribution of your outcomes. If you choose B, here's a probability distribution of your outcomes. And then the CEO would test and maybe poke holes in the analysis, and we'd go back and run it again and come back and make arguments. or not make arguments, we would present the results and let the data make the arguments themselves. So I hope that answers the question.
Yeah. And then I think the last question we can take, since we're over time, is how can data science be used in agriculture, animal husbandry, dairy?
Well, if you're asking that question, I would say this might be a case where you want to start with values, right? You want to start with what do you care about and think about what actions you can take to get more of what you care about, right? So in the field of agriculture, you may be facing decisions about how and when to apply fertilizer, how much to apply, etc. So this is a decision you might declare, and you may have a bunch of different alternatives for how best to do it, perhaps based on studies that support those things. And then you may need data to be able to do it. Like maybe I've heard a lot of like drone imagery being used in agricultural fields to understand kind of like the response of crops to various treatments. And so you can see how these things all tie together. Like we have a bunch of different alternatives about how we can work with our particular field, and then we have different data sources that can help inform it. We can apply a particular treatment, and then we can get feedback on that treatment and use that to make decisions about a different field, et cetera. So I think again, decision making pervades human life. So there's no field that this framework does not apply to in the abstract. So I think it applies to anything.
And I think that's a great note for us to finish on. Thank you very much, Brad.
Thank you, Stuart. Thanks for the opportunity. Enjoyed it. Thanks, everyone, for all of your feedback and energy.
Yeah, and if you go ahead and share the next slide. We have an upcoming webinar next Tuesday, another Simplilearn webinar. And this one is a career-oriented, especially oriented towards new grads. Expert tips for a successful career, redefining future readiness for the modern graduate. And this is the Vice Chancellor of the SRM Institute of Science and Technology, Dr. Sandeep Sanchetti. So we hope you will join us for that webinar, and we hope that you have found today's webinar useful, and you can connect to Simplilearn using our various social media handles. I think that's on the next slide, Brad. And we are on Facebook, Twitter, and LinkedIn. And Brad, people can connect with you on LinkedIn, yes?
Yes.
Wonderful. So again, that concludes our webinar today. We hope to see you at the next one. I want to thank Brad Powley again for giving us these insights into decision analysis and how it makes you a better data scientist. And I'd like to ask everyone at this point to please log off of WebEx. There will be a survey that pops up. And if you can take a couple moments to answer those survey questions, that will be helpful. Thank you again.
Goodbye, everyone.